So the difference between the direct and indirect proportions is what you're kind of working on today, indirect proportion. In a direct proportion, you have a scenario where it is, like measurement from 1 over measurement from 1 would equal the measurement from 2 over the measurement from 2. And so you kind of keep them together as one grows, the other grows, and it'd be proportionate. That's direct. But when you do indirect, it sort of flip-flops it. And so we kind of go through a different process where I would do the measurement from 1 would go with the other measurement from 2. And then the 2 would go with the 1. So I sort of flip-flop them. The top or the bottom, either way, it doesn't really matter, but it's going to change its position. Okay, so if I'm going to be doing this setup, actually, like I said, I was going to do the evens and let you do the odds. So if I'm going to do this one, I have diameter 1 goes with diameter 2 if I'm going to, well, okay, I've got to set that up. I don't want to make it confusing, so I'm going to try here. So I have the diameter from pulley 1 would actually go with the RPM of pulley 2, and the diameter of pulley 2 would go with the RPM of pulley 1. Does that kind of make sense where it's sort of flip-flopped in what you would think you would do? Okay, so that's going to be my setup for this. My diameter of 1 goes with the RPM of 2, but the diameter of 2 goes with the RPM of 1. And so when I set up my proportions, I can fill those in. My diameter 1 is 18, but my RPM of 2 is the unknown. And the diameter of 2 is 24. The RPM of pulley 1 is 200. And then you take your calculator again and cross multiply and solve. So the way of solving the proportions doesn't change here at all. What changes is the setup is the inverse, or it's kind of the opposite of what you would think it would be. So I would do 18 times 200 divided by 24, kind of the same process. So my thing here is 150 for that. So if I were going to set up B again, my diameter of 1 is 12. Here's B. My diameter of 1 is 12. It's going to go with the pulley 2. And then my diameter of pulley 2, which is the unknown, will go with the RPM of pulley 1, 300. Again, cross multiply and solve. So this is 12 times 300 divided by 240. And we would end up with 15 inches there. Okay, so let's run through some word problems in a similar fashion. Again, it's just going to be sort of organizing your thoughts. So when I do this, I read through the problem and I figure out what I'm looking at. So we have the wrench is inversely proportional to the amount of force needed. And so a 6-inch wrench needs 240 pounds of force. So I'm going to go my wrench 1 and force 1, and then how much force would be required to loosen the same bolt with a 10-inch wrench. So this would be wrench 2, force 2. And so when I set this up, I have the 6-inch wrench requires 240 pounds of force. A 10-inch wrench requires what force? And then I can cross multiply and solve just like normal. And just watch your labels. 6 times 240 divided by 10. And so that would require 144 pounds of force. So what should happen is the longer the wrench, the less force necessary. So the 10-inch wrench only requires 144 pounds of force, where the 6-inch wrench required 240 pounds of force, and that's what makes it inverse. Okay, so keep it on here. We have a 15-tooth gear on a motor shaft, drives a larger gear having 36 teeth. If the motor rotates at 1200 RPM, what is the speed of the larger gear? So this 1200 RPM is on the 15-tooth gear. So it's the 15 and the 1200. And so then we have a larger gear, 36, and speed of that. So it was the 15 to the 1200, 36 to what? So those places go in the diagonal instead of going with that direct proportion. So 15 times 1200 divided by 36, and we should have 500 RPMs. Again, the larger gear will have a lower number of rotations per minute. Number 8, similar thing. A truck driver covers a certain stretch of the interstate in 4.5 hours traveling at 55 miles per hour. And so if the speed limit is raised to 65 miles per hour, how much time will it take? So we have our time for 55 miles an hour. How much time for 65 miles an hour? So again, diagonally it goes down. Just sort of try and figure out what measurements you're looking at. Talk yourself through it. So 4.5 times 55, and then divide by 65, and we should have 3.8 hours. So it should make sense again that it's going to be less time if you're driving faster. One last one. Hopefully you get the gist, and then the odds are on your own. So if a gas has a volume of 2,480 cubic centimeters at a pressure of 63.5, what is the pressure when the gas is compressed to 1830 cubic centimeters? And we have to round to the nearest tenth here. So 2,480 goes to 63.5 as 1,830 goes to an unknown amount. I'm trying to keep the PSIs on a level. That's that measurement. I have the first scenario with the cubic centimeters to PSI on the opposite denominator, and then we'll again cross multiply and divide. So that would be 2,480 times 63.5. And then divide that by the 1,830. And I got, round to the nearest tenth, one number after the decimal, I got 86.1. I'm looking for PSI here. And again, the less cubic centimeters, the higher the PSI. The more cubic centimeters, the lower the PSI. So when you work with an inverse relationship, it's going to work the opposite way as the direct relationship. And I don't know where my recorder went, so I bet I didn't do it. Oh, found it. Okay, there we are. Have fun. Give me a call if you need any, or send me an email or whatever if you need anything.